Experience technology is a niche domain that we have which works specifically on the presentation layer, working on different frameworks and custom frameworks as applicable across clients. And my Twitter handle is rakeshmenon30. Cool. So before we start, just let's discuss some of the key takeaways of this session. The first one will be what is demand-driven architecture and what is the need for demand-driven architecture in today's world. Second is, what are the principles which govern the demand-driven architecture? Understand how GraphQL fits into the picture and what are the core concepts which drives it. What are some of the best practices when using GraphQL in your tech stack? And last of all, this is a time where we'll be spending hands-on on creating an end-to-end small application using React and GraphQL, right? And our server side will be on Express and the client side will be on React. Cool. So before we start, let's discuss a bit on how the web architecture has evolved over the time, right? So if I talk 10 years back, so what was the tech stack that you used to use? Anyone? Has anyone heard about JSPs, EJBs of the world? Who all has worked on that stack? Very few. That's nice. So there has been quite a large evolution over time in terms of web applications. So if you look at the evolution cycle, there are mutations with respect to, there are changes with respect to what you are developing today. There are some things which are selected which move forward, which are adopted by the world, that is selected, and then it is inherited to form a new web development approach, right? So if we talk about yesterday's application, right, it just consisted of one single monolithic application on the server side, and all the client-side applications were form submits, direct get request, and used to serve the page from the server side itself. There was very minimal interaction on the client side. So if you talk about 10 years back, right, so people actually used to be full stack. There was no specialization before like front end, back end. So people used to work on the server side, people used to work on the client side code. They also used to design the applications as well. So there very less focus was there on focusing on the core client side and server side concepts, right? And if you talk about today's stack, this is how it looks like. So who all are working on this kind of a stack right now? With REST APIs on the back end? Raise of hands. Right, so most of you are working on REST APIs, right? So you have multiple data sources, you have microservices in most of the cases, you have product level segregations of those services. Like if you just consider a simple hotel reservation site, right? You have a reservation application, you have a search application, you have an authentication application, and all those services are separated. And all those are consolidated with a single layer, which is an API gateway, and then your web applications, your mobile applications, and your IoT devices are using the same REST APIs, right? So all is well as of today. So everyone who is starting a new application wants to start on the REST paradigm, right? So what changed? Why do we need to change from this to a different architecture altogether? Who can relate to this? So we all own more than 3 to 4 devices per head, right? I mean, we are using a tablet, we are using a phone, we are using multiple laptops. It's not even one laptop now. You have an office laptop, you have a home laptop, and then you have IoT devices as well, right? So the problem that these applications are facing is you have to have a different API for your web applications, and you have to have a different API for your mobile applications because the feature requests are different, right? So in web applications, you need around 20 to 30 sets of data, and on mobile applications, you need 5 to 6. So, but you are still reusing those endpoints to cater to all the devices, right? Cool. So let's discuss what some of the common problems with REST APIs as of today. One, so as everyone says, change is the only constant, right? As soon as the project comes into the picture, the requirements from day 1 has a drastic difference to what is there on day 10, right? Even in 10 days, the world changes. I mean, there is a different set of requirements that comes into the picture. Then you have to create those new endpoints to cater to those requirements, right? Second is overfetching and underfetching of data. So overfetching is, suppose you need name and email of a person. But if you query for a person, you get name, email, phone number, address, and a lot of details which comes along with it. And you have to use only a couple of them, right? So you are overfetching those data. You don't need those on the client side. So there is a lot of network usage. And underfetching is, again, if you are requesting for a resource which is only giving you a name and email, and if you want the other address information, you have to hit another API to get all the contact information and then consolidate and put them on the client side. Now the third part is called versioning hell. So who has faced this problem of versioning hell? If you're using REST APIs, you have at least 2 to 3 versions of the REST APIs running at the same time, right? So how do we run into such a scenario? So you have a web, you have a tablet, you have a mobile, all being served from the same API service, right? Now, there are some new feature requests on the mobile for which you need some changes in the API, and those are breaking changes to the existing version, right? So you move the web and tablet to the same API version because there are no changes in those devices, but a mobile has moved to API version 2, right? So those are the new changes. So there are continuous improvements in the mobile space because of which the APIs have to cater to those requests. Now again, this cycle continues where now the web and tablet have moved to the API v2, and the mobile development team wants a new feature request again, which is a breaking change, and they move to API v3, right? And this cycle goes on, and eventually over the course of 2-3 years, what happens is you keep maintaining 3 to 4 versions of your APIs because there are multiple devices, multiple endpoints which have to be backward compatible as well, right? Cool. Now the fourth problem that we face is API documentation. To simply say, people don't believe in documentation at any level, right? So when there is a project incoming, there is more focus on developing and delivering features instead of documenting and helping out the other developers to understand what is available in the API, right? So there is almost always no documentation, and that is a challenge which has to be solved in another manner now. So what we do today is what is called a supply-driven architecture, right? So what happens in a supply-driven architecture? So my voice is loud, I guess. All right. So server teams decide what the clients should be using. They deliver endpoints, they decide what are the data that will be exposed to that endpoint, and then the clients consume those endpoints, right? It's not that I have to request for only 2 fields, I just request for those 2 fields and that is what I'm getting. That's not what happens. And the second challenge that we face is there are multiple client teams. You have an iOS team, you have a web application team, you have an Android team, and everyone is requesting for a different feature. So it's a big challenge for the service layer to incorporate all of those changes within the same endpoints. So that is where they run into those different versions. And there's constant to and fro between the client teams and the server teams, and there's a hell lot of chaos when you are in the middle of the project, in the middle of the deliverables, and there is no clear picture on which endpoint should be used for this. Everyone has faced this challenge, right? So eventually, out of frustration, people start to redesign the entire application. So let's do it the right way. So there is almost is never a right way to do that, because your requirements will change from today to tomorrow, and you cannot guarantee any stability on that. So that is where we introduce a new way of developing web applications, and this architecture is called demand-driven architecture, or DDA in short. We did not come up with this term. So what's demand-driven architecture? So this was a coin termed by Kovas Bukata and David Nolan in 2015, QCon, and that is mostly around the time when GraphQL was released to the world, Falcor was released to the world, and it brought about a lot of changes in the way people thought about web services, right? So this is a specific architecture where client demands what is the data that they want and what is the shape of the data that they want. And the server needs to react to that instead of the services deciding what you should consume, right? So what are some of the principles around demand-driven architecture? The first is definitely demand. So the client decides, I need these two fields, and I need that within a field called person, and I want it in a particular format. And server has to react to that. The second is composition. So I can batch multiple different operations within the same request, and the server still should respond in the same manner. I can batch those requests, and also I can create different subsets of the same kind of, like if you have a person which has name, email, phone number, and suppose address, right? So in one of the requests, I'll say I just need the name and email. In another request, I'll say I only need the address information. But I'll be hitting the same operation. And I'll be saying, these are the fields that I want. And the third part is interpretation. The server needs to understand what is the request, what are the fields it needs to bring around, what are the data sources I need to hit to bring these fields, and respond back to the client. So the entire implementation has to be abstracted out. So what are some of the implementations that are available as of today? One is Falcor, which was released by Netflix in 2011. And the other is GraphQL, which was released in 2015, but it was actually developed by them in 2012. So if I have to talk about these two implementations, we chose GraphQL for a particular reason. So in GraphQL, the data that you request for is more closer to the JSON that you receive from the backend, right? So if you have a similar format with respect to what your database query language, so you have a database which is represented in a graphical manner, the relations are set up, and then it's a query language on top of that. Kind of close, but it's still not there. I don't know where this came from, but many of the people thought it was used for client-side state management, as in it's a replacement for Redux, it's a replacement for MobX. No, it's not. It's a totally different thing. Fourth part is related to the technologies that can implement GraphQL. So it's not just JS or Node.js which can use this. There are multiple implementations as of today. And the fifth part is it's related to the React ecosystem. Why? Because Facebook released it. So Facebook released it as a totally different approach to APIs and not just for React itself. So if I have to define GraphQL as of now, what would it be? So simply said, it's a query language for APIs. So they released a specification and a reference implementation which helps you understand what is the exact implementation behind querying APIs, right? And this is a URL where you can find the specification. It's in details. But let's discover what exactly is the advantage behind it. So initially when we were exploring, we were pro REST APIs, right? I mean, we know we had to use CRUD operations mapped to the HTTP methods. We had to use resources and sub-resources. Everything was well managed. So why introduce a new concept on top of it? So when we started using it in some of our internal applications, that is where we understood that for there is just one endpoint in GraphQL. In REST APIs, you have multiple endpoints. In GraphQL, there is just one endpoint to which you send your query and you get your data according to that query, right? So we found it extremely useful to work with, and around scalability, definitely scalable because you don't have to maintain different versions of the same endpoint now. So this is how a typical query in GraphQL looks like, where you say, I need a product, I need the name, description, and within that I need a picture with which I need the width, the height, and the URL of the picture. Simple to understand, right? So this is your request. And what do you get in the response? You have a product which has a name and a description. You have a picture field. which has width, height, and URL. So your response maps to your request. You can decide what is the structure that you want. So just to do a small sneak peek of that. So this is the graphical IDE that I was talking about. So this is available as part of any libraries which implements GraphQL, and you can expose a different endpoint which exposes this IDE with you. So if I have to simply query, right, before that, if you can see on the top right, there is a doc section. So what happens when I open it? You have all the types of operations defined. If you go inside those operations, you have all the different operators you can use, what is the data type that is defined, and within those custom data types, what are the fields that I can request, right? Everything part of the documentation, and none of this has been part of any particular documentation implementation as such. It's out of the code, and it's done through introspection in GraphQL. So we'll discuss what is introspection once we get into it. So if I have to request for some data, so I can see that I can do a feedback list query within it, right? So I'll just write a query. I'll request for a feedback list, and within that, if I to request for something, so I can request an ID description from, so let's get some description from, so I get the response, right? So it's a list, and as per the documentation, if you can see, the feedback list returns an array of feedbacks, right? So it's returning me all the fields that I requested for, and it's a complete list. Easy to work with, right? Now, the first question that comes into the mind is how to implement this now. Now, I have to parse this query, I have to understand what are the fields involved, and then I have to get the response in the same format, right? Let's get into some history behind GraphQL first. So this was, as mentioned, created in 2012 by Facebook. It was open sourced in 2015 in ReactConf 15, and that is where it received enormous positive response for the kind of application architecture that Facebook had, and it was already done in ReactConf, and that is one of the reasons why people thought it's just related to the React ecosystem and not the entire world. And one of the biggest plus points for GraphQL is it's battle tested at Facebook. So they are using it end to end in all their applications, their mobile applications as of today, and we'll also discuss the brands that are already implemented the GraphQL APIs. So what are some of the operations that are involved in GraphQL? So we have a query, we have a mutation, and we have a subscription. So if I talk about REST APIs, who can tell me what all operations you can do with REST APIs, and what are the HTTP methods mapped to the same? Anyone? So how do you invoke an REST API as of today? Anyone? Anyone? Call a URL, right? There is nothing. And if you have to do a CRUD operation on the same, if you have to create some data, you have to update some data, you have to delete some data, and if you have to map those operations, do you invoke it in a separate manner as of today? Do you use the HTTP methods put, post, get for different reasons, right? You do a get to read, you do a post to create, you do a put to update, and you use to delete operation to delete some data. So that is how the servers interpret the calls. In GraphQL, there is just one method. It's a post request. Every time it's a post request. And what goes in the post request is the query, right? And what are the kind of operations that we have? So once there is a query in which you do the read operations, the one we just saw. So you mention the fields and mention the structure that I want, and then the server responds back with the same. The second one is called a mutation, in which you can do either the creation operation or the updation operation or the deletion operation. And that kind of an operation is called mutation in GraphQL. And the third part is called subscription, where you want to subscribe to any changes that are happening to any of your models and real time update your client based on the same. So let's take a quick look again. So in the docs, we see that we have a query available already, and we have tested out how to do a post request with a query. Now, how to do a mutation? So what are the mutations that are available with me? So I can do add feedback, I can do a vote up, I can do a vote down. These are the three operations that are available to me, right? So let's try that out. Instead of query, now I do a mutation. Let's call it vote up mutation. And my operation name is add feedback. So it takes up some arguments, right? So in this case, I can see that the description is a string, the name is a string, the phone is a string, and the email is a string. But then they have some exclamation marks in front of it, right? So when you see those exclamation bang, it means that it's a required field. And if you don't see that, it's optional, right? So let's send some of them. So description, test description, then I give a name, just give my name, and I'll skip the phone since it's optional. I'll just give a test email ID, right? And what it returns is the feedback type. So we'll get into how to create the custom types. So if you are going to the feedback type, I can again query these fields. So once this mutation is successful, I want the response back with the set of fields that I describe next. So I get the ID back, the name back, from back, the description, post creating it, right? So it's created a new field for me now, new data set for me now. If I go into the history and I get the feedback list again, I can see that this is now available as part of the response. So I've done a creation operation now, right? And similarly, if I do the same, right? Now let's look at some subscription operation. So within the docs, I'll open again, I'll check what is the subscription operation available to me. So the one operation that is available is feedback added, which gives me a response over WebSockets if there is any feedback added to the application, right? So like the one we just performed. So let's look at a subscription operation. I get a feedback added, and whenever a feedback added, I want the ID, I want the from, I want the description, whenever there is a new addition. Now you can see that says your subscription data will appear here after publication. So whenever there is an addition, it will send me back the data. So let's try doing that. Let's try doing another mutation, test 2, and then test 1, right? I'm doing another mutation now. Let's hide the docs. So this is complete. You can see the mutation operation. And if you go back, I've got this exact same real time, right? So this is a subscription operation where you can subscribe to any changes in your models. Anyone, any doubts till now on how the operations are working? Clear to you?
I just more interested to know that how basically this feedback added
Yes.
basically responding.
We'll do a complete hands-on on that. Yeah. I'll show you end-to-end how to set up a server and a client to work with that. So everyone understands how the operations are working, right? Cool. So with respect to GraphQL, what are some of the key differentiators which made GraphQL successful as of today? One, it has a shared definition. So if I talk about REST APIs, everyone has their own definition. So some talk about resources and sub-resources, some talk about the HTTP methods mapped to the CRUD operations, but not everyone has a consolidated understanding of what a REST API is. With GraphQL, there is only one way of doing things, so it has a shared definition across. Second, it uses graphs as a conceptual model. So whenever you work with REST APIs, your models are primarily resources and sub-resources, right? So you look for a person, look for an employee, and within that you look for a sapient employee, something like that. But then with graphs exposed, it's the only thing that the GraphQL services expose is how the data is mapped and what are the relations between two sets of data. So you can query for those data within GraphQL. Third part is introspection. So when we saw the GraphQL IDE right now on which we are working, so we saw that it gives me autocomplete on what are the available fields, right? So how does it do that? So whenever you open a GraphQL IDE, it introspects into the GraphQL endpoint, and it fetches all the schemas from there. What all are the operations available? What are the kinds of operations available? And it gives me a complete documentation and also autocomplete when I'm working with it. The fourth part is I can define my data types. So you saw that in the documentation itself, there were data types defined along the fields like string, if it was required, if it's an integer, and also I could define something like a custom type called feedback, right? Within which I had multiple fields and they all had their own primitive types. So there is a strong typing. Whenever you make a request, GraphQL checks those for you out of the box. And whenever there is a discrepancy, it calls out with an error instead of giving back the entire data. Fifth one is the developer experience. So with REST APIs, there are different ways to explore your endpoints, but then there is no introspection and there is nothing that gives you back. These are the available resources. You can hit all these endpoints. These are the kind of data that you will receive from those endpoints. But with GraphQL, you can do those introspection, and it gives back the entire list of what you can use. And the biggest point is the community. So GraphQL has spread across, and there are 15 to 16 implementation across different languages, all the popular languages actually as of today. And while the other implementations are still lagging behind in terms of visibility and community. So Facebook being the driving factor for that. So if you look at tomorrow's stack, so you have a GraphQL layer which is on top of your different endpoints, the different databases, the different external APIs that you have. You can do any kind of operation within GraphQL. So each of your field that you request for has its own resolver in GraphQL, and that can hit an API endpoint or it can hit a database to fetch that data for you, and that entire implementation is abstracted out so that the client does not have to care about how the data is being fetched and where it's fetched from, but you'll get the exact data that you requested for. Cool. So what are some of the best practices when it comes to creating GraphQL endpoints? So the first thing is you have to think in graphs. So whenever an application comes to us for development, right, one of the first things that we do is we reverse engineer, we try to decide what are the endpoints that should be exposed as per the views that are available, and then create our endpoints and serve it to the client. But here what you have to do is you have an entire data set, and you have to figure out how to expose this particular data set to the world so that they can use it in whichever way they want, right? You don't create a specific endpoint to serve data. There is only one endpoint. You just create your queries and you have a graph and your nodes available within this. So everything has one single graph, your data set. The second part is you have to think about data models when you expose GraphQL services. So if you're deciding you have to get a picture, right, you can have very specific endpoints to get details of a picture in REST APIs, and then inside that, if you want within the dimensions, you want the width and the height, you have a separate endpoint to hit that and get the data back. But here you'll only expose it in one single manner, and all the nodes will be nested within the same query. So you don't think about the view itself. Third part is it has to be a thin interface. The primary problem with GraphQL endpoints is that people put all their business logic into this particular GraphQL layer itself. So GraphQL can fetch the data for you, GraphQL can hit different services and aggregate the data for you, but then it's a recommendation that you keep it as a thin implementation and not put all your business logic inside it, right? So it will fetch the data, the business logic should be a different layer, like you do in the case of microservices. Now, if you have to move away from a REST API implementation to a GraphQL implementation, so it's quite overwhelming to do this entire change in one shot, right? So you decide on parts of the application that need to be ported. You put that, put a GraphQL layer on top of that, and have your clients hit those GraphQL APIs instead of your REST APIs. So you can, if your system is already divided into different microservices, it's much easier for you to port from from REST APIs to the GraphQL layer. And when you're deciding your GraphQL endpoints, you have to think about the client definitely. So you have web applications, you have mobile applications, and within mobile you have iOS, you have Android, and everyone has their own requirements. So when you are exposing your data, you have to think about how the client will use your data, how they can query for different aspects of your application, and within that, what are the kind of fields that are generic instead of being too specific to one single feature. And definitely a prerequisite to this will be have a client when you are starting the porting, right? So you should have one of the teams working with you to do this port in parallel so that they can use it and they can tell you what are the problems with the kind of data that you are exposing right as of today, right? So you can think about the graph models better. So if I talk about GraphQL only, right? So these are the implementations which are available for different technologies as of today. For JavaScript, you have the primary candidate as Apollo. For Ruby, we have GraphQL Ruby. We have Graphene for Python. We have Sangria for Scala, and we have 3 different implementations for Java, PHP, and .NET. So any technology that you're using as of today, you can implement GraphQL with that. And these are some of the brands that have already moved to GraphQL. They already have their REST endpoints, but they have already started porting their entire services to GraphQL. So Facebook, GitHub being the primary drivers. Then there's Pinterest, Twitter, Financial Times, Intuit, Coursera. Everyone has heard of these brands, right? Major brands, and they are already starting their port. So what we'll be doing post this is I'll be creating a server and a client itself so that you can see how those interactions happen between GraphQL. And the primary library that we'll be using for that is Apollo, right? So Apollo is one single implementation which has stood out. There are other implementations like Relay and Facebook's own GraphQL.js, but then Apollo makes it extremely easier by providing their helpers for different server-side implementations like Express or Happy or any framework that you're using on Node.js. And on the client, it has a higher order components exposed that you can use to expose the client to the React application. Cool? So we have done a lot of theory till now, right? And it's not what we came here for. So let's get into a bit of code now. And I'll start in the first half. What we'll do is we'll start with the server-side application, and then we'll have a small break, and then we'll move to the client-side application on React, right? So how many of you know JavaScript? That's a very good number to have. So everyone has worked with Node.js, React. How many of you have experience with basic Node.js? Okay. Basic React. All on the left side. Okay, so I need to know more about the right side folks now. So are you all server-side developers or client-side developers? All are client. Brilliant. So at least we have covered on that part. All right, so if we have to start with the basics Node.js application, right? And we'll use the Express framework to set up our routes and expose the GraphQL endpoints. So these are some of the packages that we need to use. So I've already installed those packages, but just to explain, some of the packages involved are Apollo Server Express, which provides a major chunk of the helpers required for the GraphQL processing. Your body parser module, which is used for JSON processing from client to server. You have a CORS module, definitely the enable CORS on your endpoints, cross origin requests. You have the Express framework, which is a web framework. And then there is a GraphQL library, which is exposed by Facebook itself. which provides a couple of helpers for subscriptions mostly. So what you will be covering throughout the application is doing the query and the mutation, which will take a major chunk of the time, and then for the subscriptions, I'll show you what are the boilerplates that you need to put in your applications as well, right? And a couple more things that we will be using is Sequelize with a MySQL implementation. This is the ORM on top of SQL. So who all know what is an ORM? One person. So ORM is an object relational mapper. So what it does is it creates an abstraction on top of multiple implementations. Like if you're using MySQL or PostGRE or some other database, it provides a common API to work with all these databases. So those operations are abstracted out from you, right? Cool. So let's start with creating a simple Express server, right? And I'm using ES6 as well. So who all are comfortable with ES6 to some extent? Well, I'm not going too deep on that. All right. So if I have to set up an Express application, the first thing that I need is Express, right? Cool. And the second part is I have to create a server instance by calling the Express method. Now what I can do here directly is I can do a server.init on a particular port and I can expose my routes. But instead of doing that, so what Express provides out of the box is just an HTTP server. So if I want to move to HTTPS or HTTP2, I have to take out those and use the actual HTTP module from Nodes itself, right? And wrap it on top of Express. So let's start with that. So let's get the create server from the HTTP base module in Node. And I create an app which basically wraps the server inside the HTTP module. And the next thing that I need to do is initialize it on a particular port. So let's define the port. Say it's 9999. So my server will be listening on 9999. Right? So this is all I need to do a basic setup of the Express server. What is the next process? I need to set up routes, right? Cool. So if I just start this application as of now, oh damn it. Oh, I'm doing an init. I should listen. That's what happens when you write a lot of code with init. Cool. My server has started. So if I try to hit this particular port, it tells me it cannot get the base URL, right? So you have to set up your routes now. So on this itself, if I do server.use, I will use both get and post requests on slash. I'll put a request handler on top of it. So every request handler in Express gets a request and a response object. Everyone comfortable with arrow functions? Cool. All right. So we do a rest.send. Let's send back an h1 with a hello. Right? So if I hit with a get request or a post request on this, it uses this particular request handler, right? Let's try that. I get back the hello, right? Cool. So the next operation is, this was not our intention, right? So these are normal endpoints and these are normal pages that you serve from Express. Now we have to do is we have to expose GraphQL endpoints from this. So before that, we have to define some of the schemas that have to be exposed from GraphQL before setting up the GraphQL instance. So let's create a new folder called src. We'll create a new folder called schema, where we'll put all our schemas with respect to different operations that we have, the queries, the mutations, and anything, right? And within schema, let's create a new file called index.js. and this will be imported back to the original server. Before that, so let's have a couple of folders within schema itself. So one will be dedicated to all your operations, which will be the queries and mutations, and the other one will have the custom data types that you have to define, which your operations can use. So if you have to start with defining your custom data types, right? So if you have seen this application, so it gives you back different databases, right? Different data types, which is feedback, results meta. So let's start with one of the custom types that we can return from GraphQL. Create a new file called feedback.js, and we have to export a string from here. So let's have a, so what I'm using here is a template literal, ES6 template literal, where you can put in variables and you can have formatting defined, right? So if I can simply define a simple data type called feedback. So what will it contain? What are the fields that a feedback can contain? It can contain the details, it can contain details of the person who is giving the feedback, the email, the phone number, and a particular identifier, right? So let's have a custom ID. Let's have a field called description, which contains the description of the feedback. A field called from, which contains the name of the person who is giving the feedback, the email of the person, the phone number of the person, and also what we are planning to create here is a view where we have multiple blocks, right? So people can give their feedback and then others can go and like and dislike, and then it will be sorted one on top of the other. So if you have to create this view, so we also need two more fields, right? Called upwards and downwards. So let's create those. Now we have to define what are the data types of these particular fields. So ID, let's keep it as an int, and it's a required field, right? Description, let's keep it as a string. We'll keep it required because a blank feedback is no use. So we'll have a from, again as a string, email as a string, phone number as well, we will keep it as a string as of now, but I'll keep it optional. Upwards will be an int, downwards will be an int. Everyone clear with this? So you have decided what is your custom type and what are the fields that it contains when I want to hit and get the data, right? Now let's get this. So what we have defined here is just a string, right? So it's not an executable schema as of now, which GraphQL can use. So we have to create those schema now. So let's get a couple of helpers from a library called GraphQL tools. So one is, if you have a string, you have to convert it into an executable schema object. You have make executable schema method exposed from the GraphQL tools. Now second is, you have to form a root query which contains a consolidation of all your schemas. And from here, what you do is, you have to import the queries and mutations. Before we do that, let's keep it as blank. Let's create the schema object, which we can do by calling the make executable schema, and then passing it two different attributes. One is your type definitions that you are defining, and the other is your resolver methods, which can resolve those particular fields. So you have type defs and you have resolvers, right? And then I export it out. Now if I have to get all the type definitions, I also have to get the root query, right? So let's define all the root operations which I want to do, just starting with a query. Let's call a field called query.js, and then export a string, which tells me if I hit the endpoint, what are the operations I can perform from the outside. So there are three basic types of operations. One is query, one is mutation, and one is subscription. So what I'm defining here is within query, what all can I query for? So the first thing that I mentioned is a feedback list, right? So this will give me the list of all the feedbacks within the application. So it has to be an array, right? It has an array of what? It has to be an array of feedbacks. And feedback is the custom type that you defined here. A feedback can contain all these fields, right? So it will be an array of objects which contains all these fields. Great. So we have the operations defined. Now in your schema index, what you do is you import this query. And within your root query, now this is how you put variables inside your template literal, right? So you get this query and you form one single unified query which contains all your different operations. So query is the only operation that we have as of now. Now within make executable schema, we have to pass all our type definitions and all the resolvers. So we have not defined any resolvers as of now. So I'll remove these resolvers and just to test it out if my queries are working, right? So within my type definitions, I'll pass one is the root query, which contains all my different operations, and the custom types as well. So whichever custom type I am defining, I have to pass that as well to GraphQL. So you have the root query, and from types you have to import the feedback type here. And I pass it as well, right? So I've given all the type definitions to my schema object. Now, since I don't have any resolvers, let's create, let's use a method called mock functions to schema. And pass it the schema object. So what it will do is, since you are already defining your data types in your feedback as well as query, right? So you have all the data types defined here. So when you pass your schema to the add mock functions to schema, what happens is based on the data type, it returns some mock data so that we can test our queries, right? So this is our schema object. Is everyone able to see the code? Cool. Now going back to our server, right? Now we need to expose our GraphQL endpoint, we need to expose our graphical endpoint so that people can query for this data from outside, right? So let's have two endpoints. One is /GraphQL, and we'll have a request handler on top of this, and the other is graphical, right? Cool. So what we have to do is we have to get two helpers from Apollo Server Express, which is our primary module, which gives up all the request handlers with respect to GraphQL. GraphQL Express and Graphical Express, right? So you have two helpers from the actual Apollo module now. Now these are your request handlers. So you have to pass your request handlers to these. And to GraphQL Express, what you have to pass is the schema. So what you have defined in the schema index.js, this particular schema object has to be passed to the GraphQL endpoints. So let's pass the schema and let's get the schema. src/schema, and if you don't mention any file name, it gets index.js by default, right? So you have passed it to GraphQL Express. Now, what you are getting from the client to the server is actually a JSON object, which contains your entire query in a field called query. So you have to pass the JSON body from here. So import body parser from the body parser module. And before it goes to the GraphQL Express, I have to pass it as JSON, right? Now same applies to both my graphical as well. So pass it as JSON, and instead of GraphQL Express, now I have to use the graphical Express helper, right? And instead of passing the schema here, we have to pass the endpoint URL. So the endpoint URL for GraphQL that we have defined is /GraphQL, right? So this is the only endpoint that the application has. Good with this? Any doubts till now that anyone has faced? Is everyone clear with the setup? We defined a schema, we defined the custom data types, and then we expose the routes and we pass the schema to it, right? So, and also your graphical ID is aware of what is your GraphQL endpoint, right? Cool. All right, let's try to hit the application now. So there is no slash. So let's open the graphical ID. So you can see that your documentation has one single query, and within query you have one feedback list, and you have a custom type called feedback. This is exposed to the documentation automatically through introspection. So when the ID opens, it sends an introspection query to the GraphQL endpoint and gets all the schema from there. And if I have to query for it, I'll say feedback list, and I can fetch for any of them. I can fetch for ID, and I can fetch from, can fetch description. Let's try to get that. So it is sending me mock data as of now. So for all the strings, it's sending me hello world, and for one integer type, it's sending me a random integer, right? So our basic GraphQL setup is complete. Anyone has any doubts till now which I can repeat so that you are clear about it? Which one? Which one? Which one? The schema part. Cool. All right. So within schema, what is the first thing that we did? We defined a custom data type, right? So the custom data type contains a set of fields, all having a primitive data type, like integer and string, right? And within the operations, what we need to define is the root query. So root, there are only three kind of operations that you have: a query, a mutation, and a subscription. So within the query, I have only one operation exposed, which is feedback list, right? And what is feedback list? It's a list of the custom data type that we are returning, right? Now, what I have done with this query is, since we have created strings till now, even for our custom data type and for our query, what we will do is convert that string into a executable schema, right, for the GraphQL endpoint. To do that, there is a helper exposed by GraphQL tools called make executable schema, which takes in a string and creates an executable schema out of it, where you have to provide your type definitions and your resolvers on how to resolve those particular fields. So type definitions has one root query, which contains your query, which contained again the feedback list, right? Till this. And the second is your custom types. So the more custom types you define, you have to send all that to the type definitions so that your schema can be processed by GraphQL. And since we have not decided how to resolve those particular fields, right? In this case, we are just adding mock functions to it So that returns me mock data. I'm just testing how my application is working till now, right? And what I did in server.js is I got two request handlers from Apollo Server Express, one for the actual GraphQL endpoint, the other for the graphical endpoint, so that I don't have to do any manual work to set up the graphical IDE, right? All I need to do is expose this endpoint. And I've exposed two routes. One is /GraphQL and the other is GraphQL Express. And the graphical, sorry. So within /GraphQL, the request handler that I've used is the one I imported from the Apollo Server Express module, which takes in the endpoint and the schema, introspects and gets the entire how to process a particular request, right? And for graphical, you need to give the actual GraphQL endpoint that you want to hit. Cool? So these two routes are the only routes that we have in our application. And the primary one which you will be using when you are creating your client will be /GraphQL. Graphical is just for your testing to understand what the queries are returning. So when you are having a production application, you will remove the graphical endpoint from here if you don't want to keep it here. Right? So we get our mock data as we wanted. So if I remove the description field, it's only returning me to ID and from. Right? Cool. Now let's do one thing. Now we have to set up the database as well, database connections to it. So if I have to create a new database connection, I'll just have a config folder here. I'll create a new file called database.js, which contains my database connection configuration. So as discussed before, we are using an ORM called SQLize, which will connect to my MySQL database. And if I can simply show you the MySQL database, it's a database called DDM Meetup, and it has a table called feedbacks, and it has these fields, right? ID, description, from, ports. I've kept it same so that there's a direct mapping for you to understand. So I have to import the ORM. And the next thing I have to do is create a database connection. So let's call it database. I'll create a new instance of SQLize, and the three things that actually you can see the documentation itself. I have to pass the database name, I have to pass the username, the password, and the configuration with the host and what kind of database I'm using. So DDA Meetup is the name of my database, the username, and the password. Convenient, right? Very easy to hack. Now I have to pass two particular configuration options. One is the host, which in our case is a local host. It's not a remote URL. And a dialect. So dialect is what kind of database you're using. In our case, it's MySQL, right? So I'll pass MySQL. And let's export this one. Right? Now, while we have this database connection, we also need to define our models so that they map directly to your database. Let's have a new folder called models. Oh, damn it, created this inside this. So I have to keep my config outside and the models outside. Let's create a new model called feedback. Again, the first two things that I have to import is SQLize again, so I can use its methods. I have to import the database from config database, and I define my feedback model. So I have to use this database connection to define my model. So use database dot define the table name that I want to use. So in my database, my table name is feedbacks, So I use feedbacks, and then I have to define a particular set of fields, their types, right? So what are the fields that I want to create now? So if I go to my types, so these are the fields that I have to contain in the database, right? So I take this particular set of fields, I get it, directly map it, I replace this with the SQLized definitions.
Can't we like directly use the already defined data type for what we have already defined for GraphQL?
No, so this is the database model that we are creating, and those are the GraphQL particular data types.
Exactly, but also the fields are same, so exactly we are just copying pasting the fields. So is there some way?
So that is a string, I can't import that and put it here, right?
Exactly.
I have to do that entire mapping, and I have to create the fields, and I have to give the SQLized data type so that my ORM understands what is the data type. Right, so this is while fetching the data, this is for fetching the data from the database. And while the other GraphQL types that you had, those are for introspection. So when you have a request hit to the server, you know this is the data type that I'm expecting. If I don't get that type, I have to throw an error. Right? So those are not for fetching it from the database. So what I've done is I have just used SQLize or string on all, but I know some are integers, like my ID is an integer, my upvotes an integer, and my downvotes an integer. So while describing your models, I also need to specify which is my primary key, which can be null, which cannot be null. So let's do those configurations. So my ID is the primary key. Definitely I can't allow null on this particular value. And sorry? Oh, sorry. Thank you. And if I go to my description, again, allow null as false. If I go to the name of the person, I will not allow a null. Email, I can't allow a null. Phone, I can allow a null. And upwards and downwards, I will keep it different. So apart from this, if you go to ID, right? So ID, I also want to increment with each and every new operation, right? So if I insert a value into the database, I want the value of the ID to increment for the next. So I have to set auto increment on this. And for email, let's try to put a validation. So you have a validate property, you can pass it to SQLize, where you have a lot of operations which are available in SQLize by default. So what I want to use is email, right? And I pass is email as true. For phone, I don't have any validations. So I need to put the comma across each. Phone, I don't need a validation. For upvotes, let's put a default value of 0 whenever a field gets initialized. Right? So whenever a new entry is added, I put upwards and downwards as 0. Right? Cool. So we have the entire database model defined here so that we can query the database. Let's export this out. Now the first thing that we have to do is we have to create the resolvers instead of the mock functions that we are passing to the schema. So let's create a new folder called resolvers. And the different kind of operations that we will be having, we'll create their folders, create a file. I will have resolvers for my query, and I will have resolvers for my mutations as well, but let's start with the query. So I have a new file called, so all the operations, right? So within the schema on query, you said you'll have a operation called feedback list, right? So I'll create a file corresponding to that within my resolvers. This.js. So to perform any database operation, I have to get the model that I just defined so that I can perform the operations on top of that. So from models, I have to get the feedback. Slash models feedback, and each of your fields will have a single resolver function. So each of your file that you are defining here has to export a function which can resolve that field. So we export a function and whatever you return here has to conform to the data types that you have defined in your schema. So what we do is we have to use the model and find all the entries. So if I have to get the feedback list, I have to get all the entries from the database, right? So let's get all the entries and let's order them by the ID so that the last one comes before and the first one comes at the last. So instead of, so what feedback.findAll does is it exposes a promise. So you can use feedback.findAll then perform the operation on top of it, right? But I'll just use async comment on top of it. So it makes our lives easier. So you have to describe your function as async. You await the operation for the fetching the data from the database since it's async and return that particular data back, right? Any doubt on what we did here? So findAll is a method which is exposed by SQLize to get all the data in that particular model that we have defined, right? And I'm sorting it by ID so that I get the last entered feedback first, right? So let's try it out. So before doing that, we'll have to create new file within resolvers, new file within query. So within query, let's create an index.js which exposes an object containing this feedback list operation. Right? And I have to get this query inside my parent list of resolvers. So import the query. And export default an object which contains the query. So I always have the number of operations that we have to have that many things exposed out, so that if you have query, you have mutations, you have subscriptions, you have to have all those exported out as inside the object itself, so that this particular object can be passed to the make executable schema function which has a parent list of everything, right? So for now we just have a query, and within a query I just have feedback list which returns me the list of feedbacks. Now let's try that. So I have the resolvers object already exposed from here. I go back to my schema index.js and I remove the mock functions now. I don't need this anymore. Cool. So instead of this, what do I need to import now? The resolvers. Damn it. Dot. Right? I get the entire resolvers object. I pass it to the make executable schema function. For now, there is only one single resolver which gets your feedback list. So let's try that out. So with this single operation, let's refresh. See, so now I have all the entries from my database, right? With a simple setup of exposing a function with respect to the operation that I have exposed the actual data out of the database now. So if you look at the database and the content, these are the 4 data that we have. So let's try to get a couple more description and email, and I get all this from the database, right? Simple to follow? Cool. So on this note, let's take a break. I think the tea and